This is section 2.2, linear equations. Start out with linear function. Basically the same thing as a linear equation is a function whose graph is a line. Then a linear equation represents a linear function. An example, y equals 2x plus 3, y equals 1/2 x minus 2. You go on and on. You'll see several of these this section. The dependent variable is the y because it depends on x, and the independent variable is x because x can be any number. Plug a number in for x, and then y depends on whatever that number is. Our first example is graph the equation y equals 1/2 x minus 2. One of the easiest ways to graph these is just to make a table of your x value, and then you'll plug it in to the equation to get your y. So you could just do -2, -1, 0, 1, and 2. This is more than enough points. Technically all you'd need is 2 in order to make a line. So we plug in -2. We get 0.5 times -2 minus 2. Get -1 minus 2. This is going to give us -3. Next one should give us -2.5. This one should give us -2, -1.5, and -1. Okay, so we go, our x is -2, which I went by. This is a positive one. So we go -2 down 3, -1 down 2.5, 0 down 2, 1 down -1.5, and 2 down -1. We connect those points with a line. Be nice. Use a ruler if you have one, or a straight edge. It just makes the line look a little bit nicer. So first way to graph, make an equation. Okay, we talk about the y-intercepts and the x-intercepts of a graph. The y-intercept is the point at which the line crosses the y-axis, and then typically that point will look like a 0 and whatever that number is. X-intercept, the point at which the line crosses the x. This one just reversed, whatever the x-coordinate is, and then 0 for the y. Standard form of an equation, ax plus by equals c. So example, graph the linear equation by using the intercepts. So 2x plus 3y equals 12. And get the graph ready. So for using the intercepts, we know that at the y-intercept, x is going to be 0. So we can essentially just use a cover-up method, which you cover up the 2x, and then you have 3y equals 12. We divide the 3, and y equals 4. In other words, we're plugging in 0 for the x, so 2 times 0 is 0, plus 3y equals 12, divide the 3, we get y equals 4. X-intercept, we'll plug in 0 for y, so 2x plus 0 equals 12. We divide by 2, and we should get 6. So we graph this. 5, 6. Apologize for my marks being off. 2, 3, 4. We go up 4 on the y. We go over 6 on the x. As I said, you only need 2 points for a line. Apologize for the bad line. If it's going through those points, obviously you'll be right. So that's how you're going to graph using the intercepts. Okay, when we talk slope, the ratio of vertical change to a corresponding horizontal change. In other words, rise over run. We've done this several times. And on top, we'll do y2 minus y1. over x2 minus x1. Okay, so find the slope of the line through points 1, 2, and 4, negative 2. So on top, our change in y, negative 2 minus 2 on the bottom, 4 minus 1. Make sure we do this in order so our points line up. Negative 2, we get negative 4 over positive 3, so our slope is negative 4/3. If you can reduce that down, make sure you do. In this case, we're in simplest form. Okay, point slope form. This is just going to be y minus y1 equals m times x minus x1, where m is our slope. So we're going to use this to find the equation of a line through a point and knowing our slope. So an example, find the equation of a line with slope of 2 and through the point 2, negative 1. So we plug in for y1, which would be negative 1 equals 2, which is our slope, times x minus 2. So we're going to go ahead and solve. Y plus 1 equals 2x. We distribute, plus a negative 4. Then we'll subtract our 1, we get y equals 2x minus 5. Now we're going to write this in standard form. So we need to move our x over, so we subtract our 2x. So we have negative 2x plus y equals negative 5. If you don't like the negative out front, it's okay to multiply this whole thing by negative 1 as long as you do the whole thing. So we get 2x minus y equals positive 5. The only reason we do that, if you check the back of the book on some of the odd ones, they'll usually lead with a positive number rather than a negative. Okay, another similar problem, write in point slope form the equation of the line through 2 points, 2, 2, and negative 3, 2. So we can use either one of those points, but the thing we need to find is our slope. So our slope, rise over run again, negative 2 subtract 2 over negative 3 minus 2, and we get negative 4 over negative 5, so this becomes positive 4/5. Now we're going to just write it in point slope form. We don't need to go any farther, so we can pick either one of these points. I'll pick this one. Y minus 2 equals 4/5 x minus 2. This is all that this problem asks for. You could sure go farther, make it in standard form, or you can turn it into slope-intercept form, which we'll talk about in just a second. Okay, slope-intercept form is y equals mx plus b, where m is our slope and b is our y-intercept. So, for example, y equals 2x plus 3, our m is 2, our y-intercept is 0, 3. Okay, here it says find the slope of 4x plus 2y equals 10. There's a couple different ways we could do this. We could get our y-intercept and our x-intercept and then find the slope between those two, or we can just move it into slope-intercept form to get our slope. So we're just going to do that. So we subtract 4x, so we get 2y equals negative 4x plus 10. We need to divide our 2. We do that, we need to divide it into everything, so we get y equals negative 2x plus 5, so our slope is going to equal negative 2. Relationship between slopes of the following. Parallel lines are going to have the same slope, so and possibly and they'll have a different y-intercept. So an example would be y equals 2x plus 2 and y equals 2x plus 5. These two would be parallel because they have the same slope and they have a different y-intercept. As far as perpendicular lines, slopes are opposite reciprocals. So, say if I have a slope of one line, which is 2, 2x plus 2, the slope perpendicular to that would be the opposite reciprocal, so it would be negative 1/2. And then it'd depend, we could have negative 1/2 x, maybe plus 3 or something, and that line should be perpendicular to this one due to the fact that the slopes are opposite reciprocals. One last example, write an equation of a line perpendicular to the line y equals negative 2y plus 3 and through the point 2, 1. So first thing we need to do, our slope perpendicular of our line is going to be opposite reciprocal of negative 2, so it'll be positive 1/2. So then we're going to plug in a point slope form. Y minus 1 equals 1/2 x minus 2. We're going to work this one out. So we get 1/2 x minus 1. We're going to add our 1. We end up with y equals 1/2 x, and we can leave it like that if we're leaving it in slope intercept. If we wanted it in standard form, we could subtract that 1/2 over. We get 1/2 x plus y equals 0. And again, we usually don't like fractions, so we can multiply this whole thing by 2, maybe negative 2, and we end up with x minus 2y equals 0. This, and this are all the same thing, and they're all acceptable answers. So if you left it like this, you would have the correct answer. Okay, for tomorrow, do one problem from each quick check. So you have 7 problems that you should bring into class tomorrow and have ready on the board. If you have any questions, make sure you bring those, and we will do plenty of examples on Tuesday.